Okay, so this is 5.6, radical and rational exponents. Rational is just another word for fractional. So I'll just write that here in case that makes more sense to you. So just FYI, remember radicals are like the square root sign, and then rational is just fractional, right? Meaning a fraction as an exponent. So we're going to write the following. We have one more exponent we have one more exponent rule. This rule converts between radicals and fractional exponents. Okay, so I'm going to now introduce the rule. This is like the key part of the lesson. So if I have something like this, so let's say I have the root sign, and then I have x to the power of m, and it has a root of n. So this right here is what we call the root, and this is what we call the power, and this is what we call the base. If I have something like this, I can rewrite that as x to the power of m over n. Okay? So the power goes at the top and the root goes on the bottom. So what I like to think of this as is I like to remember the following. The inside goes on top, right? So whatever's on the inside, in this case it's m, that's what ends up going on the top, which means the thing on the outside goes on the bottom. Okay, so let's actually like practice this. Like let's say we had the cube root, so that means a root of 3, cube root of x squared. So again, I have to ask myself, what's on the inside? Okay, 2 is on the inside, so it's going to be x to the power of 2 over, and then 3 is on the outside, so 2 over 3. We can do another example. Let's say we have the 5th root, so that means a root of 5, of x to the 3rd. Again, I'm asking myself, what's on the inside? Well, 3 is on the inside. So I'm going to have x to the power of 3 over 5. Okay? Now let's say I have something like this, square root of x to the 3rd. Now square roots, since they're so common, we actually usually don't see a root, right? You usually just see the symbol. But there actually is an invisible root here, and the root is 2. Okay, so if you don't see a root, you put a 2. Okay, so this is actually going to be x to the power of, well, the inside goes on top, so 3 over 2. And the last example I want to show you is, let's say we have the cube root of x. Now this x doesn't have an exponent, but there is an invisible exponent. The invisible exponent is 1. So it's going to be x to the power of 1 over 3. Okay? And then similarly, we can go the opposite way. Like let's say we had x to the power of 7 over 3, and I want to rewrite it in radical form. Well, I have to think to myself, okay, inside goes on top, so the top is 7, so I have x to the 7th on the inside, and 3 on the outside. The 3 is the root, right? And then, let's do another example. Let's say I have x to the power of 3 over 4 equals, I want to make it like a radical. So again, the inside goes on top. So x to the 3 is on the inside, and 4 is on the outside, okay? So what we're going to do now is we're going to actually use this rule to help us simplify expressions, okay? So we're going to write the following. We can simplify, oh, sorry, that's not what I meant to say. We can use this rule to simplify expressions. expressions or equations. Okay? Let's say we had the following. So this is an example. We're going to do 2. Let's say we have x squared to the power of 2/3 times the 4th root of x to the 3rd. Now, when you see a question like this, your first step, and I should have written it here, your first step is to change all radicals into fractional exponents. So the first thing that I want to do is I want to rewrite this as a fractional exponent. And so I have to remind myself the inside goes on top. So this is the same thing at x to the power of 3/4. And then I'm going to copy down everything else. Now from here, this is just a problem. This is a problem that you should know how to solve, right? This is the same as the last lesson. Let's first get rid of the parentheses. So to get rid of the parentheses, I have to multiply. So I'm going to get x to the power of 4/3 times x to the power of 3/4. Now I'm going to see if I can combine by adding or subtracting, which in this case I can, right? Because they're being multiplied. So I can add the fractions together, right? I'll just write it out so we have it. 4/3 plus 3/4. If you put that in your calculator, you're going to get x to the power of 25/12. I have now simplified this to one fractional exponent. I've simplified it completely, okay? On delta math, you may see something like this, and it's actually just the same process. It's going to give you like an expression like this. Let's say we have the cube root of x over parentheses x to the 1/2 over 5, and it's going to be equal x to the a. And it's going to ask you, hey, what is this a? What is the value of a? And so when we have a question like this, again, we just need to focus on the left side, okay? And so my first step, change the radical into a fractional exponent. So I have my invisible exponent of 1. So I have x to the 1/3 over parentheses x to the 1/2 to the power of 5. Now to get rid of the parentheses, right, we're going to multiply. So I have x to the 1/3 over x to the power of 5/2. Now we're going to combine by adding or subtracting. In this case, I subtract. I do 1/3 minus 5/2. When I put that in my calculator, I'm going to get x to the power of -13/6. And so I'm going to bring this down. This is equal to x to the power of a. So what is a equal to? A is equal to -13/6. Because in order for this to be equivalent, the exponents need to match. So a is -13/6. Okay? So try the practice. Again, the first step that you need to do is change the radicals into fractional exponents and then go from there.